Hello students, myself Kalpana Sagar, Assistant Professor, CO Department and Assistant Dean Academics Kite Group of Institution. In today's lecture, we are going to study the 8253, which is a programmable interval timer. It is a timer chip. Let's have a quick look on the major highlights of today's lecture. We are going to study the real-world example supported by 8253. Why do we require it? What exactly it is? Difference between 8253 and 8254. Features, component, advantages, disadvantages, and applications of 8253. As I told you in the beginning of today's lecture that 8253 is a timer chip. Let's try to understand how does a timer perform its operation. If I set a timer for 1 minute, then it will count for the 60 seconds because 1 minute contains 60 seconds. In this way, the 16-second delays are created. So now question is, who creates this delay and how? Answer to this question is, it is a timer who creates the delay, and it creates the delay by counting. So come on students, now you can correlate it with the real world example. It is the real time clock who uses this 8253 IC. But in complex application, requirements would be different. Some applications require greater delays, some application require shorter delays. So greater the count, greater is the delay. So solution to this problem is to use the 8253 or 8254 IC. Let's try to understand why do we require 8253. As I told you that 8253 is a timer chip. So it is used to provide the certain delays so that we can have the accurate time interval. It is designed by the Intel, and this particular IC does the counting in such a way that it frees the microprocessor from the counting task, and this microprocessor can execute the other program in the memory so that the overhead over the microprocessor can be reduced and we can have the effective utilization of the microprocessor. Once the counting gets started from the highest value to the zero value, then this microprocessor get interrupted so that it can come to know that now microprocessor have to execute the next task or have to perform the next counting. Now let's try to understand what exactly it is. 8253 is a Intel's programmable interval timer and counter IC. I have highlighted this word programmable. Programmable, it means that the different application need to have the different time delays, means their requirements would be different. So as per the different requirements and the situation, we can do the programming of 8253. But this 8253 does not have its own instruction set. Then who will control this 8253? It is none other than microprocessor. So at last, 8253 is nothing but it is an interval timer or the counter to create the delays so that we can get the accurate time. And due to this reason, we can do the programming for this IC as per the different requirements and the situation, and that's why it is called as programmable interval timer or the counter. Let's try to understand the differences between 8253 and 8254. There are the different parameters on the basis of which we can differentiate these two. 8254 is a superset of 8253. 8253 is operational at the operating frequency 0 to 2.6 MHz, whereas 8254 supports 0 to 10 MHz. In 8253, we use NMOS technology. The N channels are used so that we can have the higher speed, whereas 8254 supports HMOS technology, high density short channel, in which the size of the device gets decreases, but the computing power gets increased. There is one important difference between the two, that is of the readback command. This readback command is not available in 8253, whereas 8254 supports this readback command. Now let's try to understand what is this readback command. See, in the beginning of the lecture, I had given you one example of the timer where we set the timer of 1 minute. And for that, it counts for the 60 second, means 60 times it counts, through which we get the delay. So we initialize the count with the highest value, that is the 60 in this case, and that count value keeps on decremented from 60 to 59, 59 to 58, and so on till it becomes 0. So in between there are so many count values will be generated. So if we want to access that count value, then that feature is supported by this readback command. So in between decremented value of the count, we can access the current mode, the current status of the different counter, that will come to know later on in this lecture. And these different information, we can access these information with the help of the readback command, whereas these features are not supported by the 8253. We only know the initial and the last value of the count. The next important parameter is the command interleaving. Again, this command interleaving is not supported by 8253, whereas it is available in 8254. Now, what is this command interleaving? Once we read one byte from one particular location, then we cannot write a new byte on the same location. So it means that the command interleaving is not supported in 8253. If we read one byte from a location and can write a new byte on the same location, then it is called as command interleaving, and this particular feature is available in your 8254. Let's try to understand the different features of 8253. 8253 contains 3 down counters which are of 16-bit each. Down counter, it means it performs the counting in decremented manner, means in downward direction, as in from highest value to towards the lowest one. It has various operating modes. The 6 programmable counter modes are available in 8253. As it is a IC, then in order to make it operational, we need to provide the power supply, which is plus 5 volt in this case. The IC pin are 24 in 8253. We have the readback command support in 8254. And these IC are compatible with TTL, that is transistor to transistor logic. The operating frequency, we have just discussed that 8253 have the operating frequency 0 to 2.6, whereas in the case of 8254 it is 0 to 10 megahertz. So at the end, when we get the count value equals to 0, one pulse will be generated, and that generated pulse will interrupt the microprocessor and will inform the microprocessor that now it has to execute the next task. Let's try to explore the various components of 8253. This 8253 contains the counter, which are 3 counters in 8253: counter 0, counter 1, and counter 2. These are the 16-bit counter. Okay, and these are down counter. It performs the counting in the from highest value to the 0 value. Next, we have the data bus buffer. This data bus buffer is of 8-bit. It is connected with the internal bus of 8253 and the system bus. It carries the data from the microprocessor on and keep it on the internal bus, so that that information gets travel from this internal bus and gets stored in the control word register. Next, we have the read-write logic. The input to this read-write logic are, we have read signal, write signal, address line A0 and A1, which are used to select the one particular counter, and we have the chip select. So these inputs are provided by the microprocessor to 8253 chip. If we have the low value for this chip select, then only the 8253 IC will be enabled. If it is high, means if contains one value, it indicates that the data bus buffer, which is here, it enters into the tri-state or the high impedance state, which indicates that the data bus buffer will have the data, but it will not transfer the data either in this direction or in that direction. Now the next component is control word register. This control word register is also of 8-bit, and it contains the 8-bit control word that we will study in the next lecture. Now let's have a look on advantages and disadvantages of 8253. This 8253 can be used with almost any microprocessor, means higher capability microprocessor which are of 16-bit, 32-bit, like that. We have the readback command which is supported by the 8254 that allows the user to check the in-between values like the count value, the current status of the counter, and the current mode of the 8253. But the disadvantage is that as it is an interfacing device, so it makes the circuitry complex. These are the various applications of the 8253. 8253 can be used to generate the square wave, waveforms, and it can be used in the complex motor controller. In the next lecture, we will discuss the internal architecture and pin diagram of 8253. Thank you, students. See you soon in the next lecture.